In the last episode of this Nixie clock build, I cut out the interior section of this piece of material. This is going to form the center plate for the body of the Nixie clock. I put the bandsaw in from the outside edge and cut along a line which lined up with this edge here, and then removed the whole centerpiece, and I glued together the joint just with PVA glue, and I cut a filler piece on the table saw to take up the gap where the saw entered. So what I'll do now is I'll just trim off that excess there, clean up the inside, and then profile the outside. I was so embarrassed by the state of the blade on my bandsaw that I replaced it, and I just tried it out now and it's working much better. I can't believe I didn't check that. I did have a brand new one there. It should have been a simple matter to change it out, but I didn't. At least I'll have a sharp blade for doing the exterior of this part here. So I'll leave that. I'll trim that off later. I just need to bring this to the line now all the way around. I might try using my spoke shape doing most of it. Problem with this timber is that the grain is so interlocked that it almost doesn't matter which way you plane it. We end up with tear out and dig-ins and so on. Okay, that's pretty good, so let's go and cut this with the new sharp bandsaw blade. That piece now is finished in terms of shaping it anyway. I do need to get the burn marks off the end grain there and drill these corner holes, and they will match the registration marks in my acrylic pieces. So I'll probably use one of those as a template to drill those 4 holes. One of the things I mentioned before was that a good thing about marking up with a laser is that when you're prepping an edge or filing to a line, you can see the beginnings. Where am I? Hang on. Here we go. You can see the vector cut edge starting to appear as you remove the waste material from that line. So in the position where you're standing, it's not always easy to see the line, but as you approach it and the waste starts to come off, you will see that depth of cut that the laser has produced. And of course, the deeper you go, the more obvious it is. But I use almost a minimum power setting on my laser, so I didn't go too deep. Otherwise, you've just got like a black curve that you need to remove all the way across. Of course, those of you who own a CNC router are probably looking at me doing all this and saying, this guy's nuts, I've got a machine that does this much better. And yes, you have. My problem is that I don't own one. My shop's just not big enough at the moment. Maybe if I sell the wife's car. Oh, for f***. Well, that's almost a brand new router bit, and it's burning really badly on that end grain. This timber is, I don't know, it's very difficult to work with. It's sort of very hard, a lot of interlock grain. It's going to be a nightmare to get all that cleaned up, get rid of those burns. Ah well. Oh, here we are, it's the next day. I've made some progress with assembling this lower section of the casing for the clock. So my initial thought with assembling this was to simply put registration pins through these four corners here, and they would pass right through the 6 acrylic plates and the centerpiece and somehow register with the bottom of the clock module here. Afterwards I thought, you know what, I can make that a much more rigid, better engineered solution by taking countersunk head screws, passing those right through the base and then fitting a hex nut in a pocket underneath. There was another reason why I considered this, and that is that at some point I'm going to have to cut a pocket in the front of this assembly, and that's to take this hygrometer module that I purchased, and it's more or less decorative. It's going to go in there just to provide a bit of visual relief with all this timber here, and I'm going to put an aluminium ring in the front of this assembly, and these little modules got a silicon insert that allows you to just pop it in and it just stays there. So I'm considering doing this on my CNC mill, just routing out the pocket, and to do that I'm going to have to be able to clamp this tightly together, trying to make it into one fairly rigid piece so that when the cutter hits this it's not going to chatter and break any of this material. So that was part of my reasoning for fitting these corner screws and being able to tighten that right up. Another useful process you can go through with a laser cutter is to, as I say, wrap a prototype. This part is eventually going to be made from aluminium plate, and the idea is that's going to screw down to the top of the assembly, and the tubes, the Nixie tubes, will actually protrude through this set of 3 odd-shaped holes. I wanted to screw that plate down to the top timber plate here. When I drew this up on my CAD program, it's very easy sometimes to not look too carefully, and when I cut this on the laser, I realised that these front 3 holes were going to sort of half miss the timber work, and if I'd gone ahead and machined that in aluminium, I would have wasted a lot of time, would have to redo it. So I just cut one out from acrylic, put it on there, realised straight away that I've made a mistake, and these front 3 holes are going to have to move forwards by about 3mm, so they match the offset with the back 3 holes. So at this stage I'm going to give all of the wood parts a coat of sanding sealer. This is mainly just to protect them from oil and rubbish and dirt while I go through the rest of the process of machining this pocket in the front here. Once I'm satisfied that I've got all my metal parts made and fitting, I'll sand that back and give it a top coat. I'm not going to show the spraying process. If you look back in one of my previous videos, which I did on the samurai knife block, you'll see the process that I use. So the next time you see these, they'll be lacquered, at least with the sanding sealer, and we can move on to all the metal machining. The timber work came out pretty good. If you saw this after I'd done the routing process, it was all burnt. I spent a lot of time just hand sanding all of that and getting all the burn marks off and cleaning up the grain, and I'm pretty happy with the outcome. It's starting to look quite nice, and I think once the lacquer goes on, it's going to look really rich and beautiful. So let's move on. We're going to do some metal machining, probably coming up next. I've got a piece of 3mm aluminium stock, and it's screwed down to a piece of composite decking board. I've got some of this stuff left over from a job, and I find it's really good for making sacrificial pallets for cutting sheet metal parts. It's really dense and heavy, and it doesn't damage a cutter if it hits that surface there. So, and plus they're sacrificial. You can chuck them away once they get all chopped up and drilled up. So I've got a center drill set in here, and the first step is to drill a series of fixing holes, and also the centers of these holes where the neons will protrude through. So let's see. Okay, that went okay. I'm a bit worried that this stock isn't held down perfectly flat. I noticed that it was flexing downwards a little bit when the drill hit that, and it might be a bit of an issue later on when I go to chamfer that edge. But what I'll do now is go ahead and do the outside profile, and then we'll clamp that down with some finger clamps and have a go doing the internal pocket. So I changed out for an 8mm 4-flute end mill, and just did a trial run just to see if I had my Z right. So the process now is to go around and do this outer profile. See how it goes. You could get to see an almighty tool crash. that was pretty ugly. That was sort of reminiscent of watching a tractor ploughing a field. That cutter, it's going to have to be scrapped, I think. Still got it done. What I can do now is just chamfer that edge, and I've got a brand new cutter for doing that, so that'll remove all those burrs, and then there's nothing there a file can't fix. So I'll set up for the chamfer cut and then we'll have a look. I think I need to clean my lens too. I've swapped out my cutters now. I've got a, it's actually a wood chamfering bit, for a router chamfering bit. Tungsten carbide, brand new. I'm hoping this will cut this okay. Okay, that's not bad. It's a bit rougher than I was hoping for. I might slow the feed rate down a bit. I'll go a little bit deeper on the Z and do another pass. Alright, well, nice chamfer, but it turned out way deeper than I thought it was going to go. I don't have a lot of material between the edge of these screw holes and the chamfer. I might just get away with it, I think, if I use some little tiny countersunk head screws, or I've got some round head screws that might do the job. Anyway, I'll go ahead, cut out the pocket on the inside. Well, I just caught the tail end of that pocketing operation, and I swapped out the cutter, and boy, what a difference that made. So I've decided to do these two pockets separately, and that way I can keep the screws in this section of the plate, because this clamping arrangement's not that great. It's a bit precarious really. So I'm going to swap out these screws, put them over here, and I'll put some sort of a washer or a clamp on there, and then we'll have a go at the other pocket. I've just reset, put some extra clamps on here, and done a new tool path. So flush with the success of using my sharp cutter, we'll just see how we go with this one. Okay, that went pretty well. Well, that part turned out way better than it had any right to. When I first saw the quality of that cut that I did around the outside on the profile, I was pretty sure this was going to end up in the bin, but it's actually turned out pretty good. I ended up cutting the little pockets with the round head screws that'll hold this down to the top plate, and I've just gone around and broken that sharp edge all the way around all the openings, and it still needs a lot of cleaning up, but that's getting close. There are two holes which are still to do something with, and one of these is for the light dependent resistor. So this little light dependent resistor is going to be used to dim the clock at night, and the other hole is for a single push button switch which controls all the functions of the clock. The original switch that I used when I was building this was a large single pole, single throw plastic switch, which I don't think suits the style of the clock, so I'm going to scrap that. What came with the kit was a little tiny tactile switch, and I'm going to fit that up through this hole here and make a little push button to activate it. So that will need to have a little circuit board made so I can solder on the connections, and it'll be attached to the timber plate up under here somehow. So I'm going to finish off the metal part, the metal parts for the top of the clock by making a grille that goes into this vent here. I had a look for some mesh that might be suitable and couldn't find anything, so I'm going to make that by drilling a series of tiny holes in a piece of aluminium sheet, and I'll powder coat that in black and fit that underneath this plate here. Well, that's my little bit of custom mesh or custom grill for the vent on the clock. I'm going to have to deburr all of that and trim around the outline, and I'll powder coat that. So that part's done, and that's going to be visible through that little window there. Cool. Lots of deburring. I've just deburred that drilled panel, both sides, just with a sanding block and some emery cloth. And that pattern of holes now will fit into the opening in the bezel. So what I'll do is on the back of the bezel, I'm just going to cut a pocket and then trim this piece of aluminium sheet to fit into that pocket there, so that when I assemble it, it's just clamped down to the timber plate. The grill assembly for the cooling slot in the top of the clock is now finished. I ended up drilling a large piece of aluminium stock. This is 1.2 millimeters thick, and I made a laser cut template which fits in this pocket in the back of this plate, and I machined that pocket as a second machining operation. Took forever to set it up and get it accurate, but it's done, and this laser cut template fits in that opening with a little bit of clearance, and I was able to place that over the drilled stock and just simply scribe around that, rough cut it with a pair of snips, and then finish it with a file, and that will eventually just sit there. I don't think I'm going to bother gluing that in or attaching it anyway. It'll be clamped down when it's screwed to the top of the clock anyway. I've been looking for a place where I could naturally break this video before I move on to part 3, and I've decided that I'll break it here. I've actually finished all of the flat metal parts that go on top of the Nixie clock now. So this is the bezel plate and the little screen that's going in the back pocket there. And I've also finished the little ring that goes in the front of the clock. This will take the hygrometer, which just sort of pops in there. One of the reasons why this is a bit out of sequence is that I've had all sorts of issues with the anodizing process, and although I shot a lot of video of that, I had multiple failures and decided in the end to just give up on it. And I completely revised the way I do the anodizing, and I'll show that in the next video. So I'll wind this part up here, and in the next part of the video we're going to have a look at the metal turning for the legs that fit at the corners, and finishing those and doing all the powder coating and anodizing on those as well. So for this part anyway, don't forget to add a comment if you feel so inclined, and give it a thumbs up. All my subscribers, all 5 of them, have told me to keep going with these videos, so that's what I intend to do. So for now, thanks for watching.